by Bernhard Wiedemann.
Hello, everyone. Hello, Lars. And today I'm going to talk about my hobby project for openSUSE, which is now to be found on openQA.openSUSE.org. And we will cover what it is, why do we really need it, and what's good for, and all the developments that have happened in the last years, like gradually improving everything. But before we start, we have a message from our sponsors that says we are looking for people who know how to write software, test software, sell software, or manage software people. And if you are or know someone, there's the address, and it would be nice. Yeah, what is it? openQA is a fully automated framework for testing a whole operating system. And what that means is that it's so automated that it's testing right now, and it was testing 6 hours ago when I was still sleeping, and we can have a look at the results right now and not have to wait for something. And yeah, and how we got there? No, but first we want to cover why do we need it? One problem we had with openSUSE, with Factory, was that there was or is so much change all the time. And furthermore, our Linux distributions became a bit complicated. Like you have this library here that opens a socket to that library, and then there's a program interacting with all of this mess, and you can have bugs appear in really weird places. Like we had one bug in libkde where your k-help center would just default, and it was because we did a small patch to the GNU compiler, and it happens. So you have all this complexity, and it's really hard to manage with just unit tests. So we have tests for compilers, but they're in no way complete. You can't. Actually, you can't even test something as simple as A plus B, because there are 4 billion values for A and 4 billion values for B, and you can't actually test all of them even. So it's even harder to test a full program under all circumstances. It's not really possible. So, and the other reason why we needed automated testing is because we don't want to lose users to crashes. Well, it's not as bad like with Mercedes, which crashed, but it can be bad, because if a user sees a crash, oh, his favorite program doesn't work, okay, maybe he uses something else, because there are so many Linux distributions out there, and they're all so easy to try. So, and we don't want to make our users unhappy. We want things to just work. So when I really started in, I think, 2009, to join the openSUSE testing team, which Holgi Sickenberg started, I took the part of the installation testing, but there I thought, I find your lack of tests disturbing. So there was not really much. The testing that was there was done by people, and we often had tests that were just breaking, like an ISO that would not install, and it was released as a milestone because nobody really tried this version. And if you can't install it, you can't test all the software behind, so it's bad for testing overall. So you get not good quality afterwards. So I tried to start some manual testing, like burning a CD or putting it on my USB stick and then booting up the machine and doing the install on my machines, and then there appears this welcome screen and I type next and I type next again for the other screen, and then I have to wait a bit and then I type my username and my password, and then next week comes the next version, and it turned out it's a bit boring to do this again and again. So being a software developer, I know about the three chief virtues of programmers, and the first one is laziness, which means I want to put a lot of effort into not working so much, so I automated everything. And the second virtue is impatience, which means I don't want to wait so long. So I made it run automatically, so the result is already there when I want it. And not I run it and then I have to wait for an hour to finish. That makes a difference. And the third is hubris, but that's not so important here. Yeah. So what I did was I made a very simple thing in the beginning. That is, it takes that ISO, a new ISO that comes out of the build service for factory, downloads it from there, runs all the tests on it, and has a nice result. And as a result, in the beginning, I just had a video, because I will explain later. Yeah, and these days there are more results, which are nice to view also. And of course, we don't just have one version of openSUSE. We have our live CDs for KDE and for GNOME. We have the net installs, we have the DVDs. And on the DVD, you can install with different desktops. So there are really a lot of variants you can have. And to cover some of these variants, I made some simple test scheduler. And that would first do the basic stuff, like the default install when you just click next, next, next all the time. And if there was time until the next ISO came out, it would then cover more extended stuff like other desktops, or installing on LVM, or with crypto enabled, or with ButterFS, which is still pretty experimental sometimes. And so there are maybe, don't know, 50 variants and combinations to do with this testing framework. And they're not run all the time, but randomly you get run each of them maybe every other day. So, and what it's really good for is one is install testing, because that's the most important part. If you can't install the distribution, you can't really use it as a user or as a tester. And second, we test upgrades from older versions. I have some pre-built images of previous versions, not just of the very last one, but also some of the ones before, because people always try to skip versions, because otherwise they change their system too often. And we really found some nasty bugs, like in 12.1, it was one day before the Gold Master, we found that you could not upgrade from the previous version, and it would just break your system, because we changed dependency in RPM and Bash, and then it created a cyclic dependency and deinstalled or no, upgraded libz, and with a new libz you could no more run RPM, and then it broke. And we found it and we fixed it one day before Goldmaster, and everyone was happy ever after. And really, when I found this thing, I thought there was really no way we could have found it otherwise, because no one tests this ISO one day before Goldmaster, because we don't publish it for the press to be happy, and internally most people just try the install but not the upgrades from older version, because there you need some older version to upgrade from. So just as one already was a big thing, and there are more like I kept a list of things I found there, and it was hundreds of things, not all that big, but useful, very useful. So we had some application testing. So besides the install, when the install is finished, the framework goes on to test some of Yast and Zyper and some Firefox and LibreOffice and KDE software and some GNOME software, depending on the desktop. So the very basic tools of openSUSE, which our users need, will be there, will be tested. And no, we are not yet done. We had regression testing. Sometimes I found bugs, and I said, I don't want this bug ever to creep in there, because we had some nasty bugs, like ETCM tab not being a symlink, and then tools would behave strangely. So I added a test, and then we get a okay or failure for this one test. And so, yeah, even bisecting. If you know Git, you know, if you find a bug and you know, oh, this was working 4 weeks ago, you can go back in the Git history and find the exact change that broke it. And that's very helpful in Git. And I have done it a few times with openQA, where I saw, okay, here's a new failure, and but I know it worked before, so I went back through the old test results and saw, okay, here on November 16 it was working, and here on November 17 it was breaking, and then I could go to the commit archives on openSUSE and see what changes went in there in between. And in the change you have always an email address of the guy who did the change, so you can ask him, hey, you did this change, and now this is broken, and usually he says, yeah, okay, you are right, and then it's easy to fix. But otherwise it can be quite hard, especially for outsiders who don't know everyone in SUSE or every contributor of openSUSE who does something. So these things, and then we even used the result videos in marketing in the past. Like on conferences where we have big screens, you can have these videos running. I think I should have a video somewhere. Yeah. Okay. Yeah. Let's have a look at the site. We have these results here, and let's pick one of the good ones. Yeah. Okay, this one looks good. So we have the video here, and there you can see, hopefully, yeah, the virtual machine booting, the ISO, and typing into the bootloader character by character, which is using the KVM kernel virtual machine technology, with its monitor interface, where you can say send key X, and it will type in an X. And with this, I have some macros that say types a string, and it will type. And then I have more macros, like wait until the screen is no more changing, wait until the CPU of the KVM process is no more running, so it's idle, so I know if it was doing something, now it's finished. So yeah, so it does all the installation step by step, and creates this nice video. And I even have a special nice variant where it skips the ugly parts of the tests, where it's really just doing regression testing, which no one is interested, but keeps the parts where it runs Firefox, for example, and LibreOffice. So in the end, we have a nice video the users can watch and see openSUSE in live action, and that's good for marketing too. Yeah, and our documentation team uses these screenshots for their manuals as well, because I have them here in perfect quality, and they don't need to go around and always fetch the latest version themselves. So that's also a really nice use case there. Yeah. So here it's booted now, and yeah. And of course, the nice thing about videos is that you can skip forward and backward and if it's too boring for you, and you can say, okay, oh, what was it, and go back and see it again, and yeah, like this. So that's really nice. I don't understand.
I'm sorry. How did you say you are capturing this video?
Yeah, very good question. That is using KVM, where we have the virtual machine, and we can not only say send key X, but we can say a screen dump file name, and then it will take the current screen frame buffer and dump it to a file. And I send this screen dump every half second, so I get a lot of files in the end, and when the test is finished, I just take all these 4,000 files and say, okay, FFmpeg to Theora, make me a video of this collection of files. And then it just creates a video out of all these screenshots, which is this one here. Actually, the main script to call for running a test on a ISO image is called ISO to video, because it would take the ISO and sort of make a video from it. Yeah. And no, let's go test. Where are we? No. Okay, and besides, there are some areas where we could use it some more, but we don't actually do it much. Like in the future, there was the idea that we could use it for gating, like testing updates of core components to see if they break something, which would be gating, and benchmarking, because we have some performance numbers. Question?
Yeah. I've noticed before that you are opening LibreOffice and you're typing there into calc or to write. How would you find out if something was going wrong, if it didn't do what it's supposed to? How do you get the result back and say that, is it just the video that you get to see, or is there some other sort of feedback that you're capturing?
Yeah, there's some feedback. It's very simple, because we get the screen output, and for that, initially it was just a video, which you can still view, and it's faster than installing everything yourself. But we did some automated checking using the screenshots, for example. And say you have your LibreOffice and you type in "Hello World," so if it really worked, there should be "Hello World" be on the screen. So we say, yes, we have the screenshot, so in this area there should be something looking like this. So we have reference images, which we compare. In the older version, we compared it bit by bit or with just small differences in the single pixels. But in the new version done by our great openSUSE team, we used openCV, the computer vision library, which can do more sophisticated matching, like it's a bit off or miscolored, or and still recognize the thing. So so we can take screenshot output and match on it. And we can have known good results, and we can even have known bad results. Like, we know if it fails, it always pops up this error message, and if we see this error message, it's again a reference image, but we know, oh, that must be a bad result, and we don't have to look very closely to recognize this bad result. But if we see something which we never have seen before, like no known good and no known bad, then it's marked as unknown. And that is when someone has to have a look, like, is it okay if it's still a good result, you make a new reference image from the screenshot. And if it's a failure, you have to file a bug or tell someone at least. So that's the process for finding bugs mostly. There are some more ways to communication, like we have a serial console, an emulated one, and we can produce output from the VM to the serial console. And when we see the output on the outside, it means the program was really working to that point and not crashed before something. And we also use it a bit for synchronization, like when we run zyperdup and it takes a real long time from the outside, we don't really know when it's finished and when we can continue typing what we need. So we can just send something to the serial console after zyperdup finished, and then when we see that, we know, now it's finished, and continue. And that part is also nice because it's very reliable, while the screenshots can be changing because fonts can be a bit larger or smaller, or change the font type because there are frequently changes to the free type library and they create some variations. So, and we had benchmarking, yeah. So we could even watch the speed and the CPU usage of everything, but we don't do it much for now. Because one of the reasons is that we run multiple tests at the same time, so they could, in theory, influence each other a bit. Because yeah, they have to change, share. They have to share their CPUs. So, and now I have a list of the improvements we made in the past. Like we have a nice result overview now, which I should show. No, not this one. Yeah, like here, we have a test. Oh, come on. We have a test here for the bootloader and for the welcome screen, and it knows when it's interesting to look at something, so it takes a screenshot, and you see here we have the welcome screen telling it's milestone 3 and it's a beta version, so that looks good. And then further down, come on. Here we have it marked as green because it recognizes some part of the screenshot, and the recognized part is here marked by a blue bar. And yeah, then here we have some yellow ones which are marked as unknown, because here it did something strange, like there's some problem. Maybe nothing major, but it broke this test. So it makes it much more easy for someone watching these results to see, okay, and here's something they should have a closer look at. Oops. Yeah, so we have these nice web interfaces to all the results currently, and we have a fast SSD, so we can run multiple tests in parallel with make, which is used to parallelize because it's a nice tool already. And yeah, we can even test other Linux distributions, and not just Linux, even FreeBSD and OpenSolaris I tried some years ago, and it's all possible, and I did it. And it's actually pretty easy, like it took me 1 day to do 2 distributions only, so yeah, easy to do. So
what sort of volume requirements does a single test take? I mean, all of these screenshots would require how many gigabytes, and how many, what sort of storage requirements you are putting aside for testing?
Usually it's very low on requirements. You have screenshots, some 5 to 10 gigabytes maybe. If it's much, then you need some storage for the disk images where you install the distribution on, which is another 5 to 10 gigabytes. So if you just want to do a single test at a time, you need maybe 20 gigs, and that's more than enough. And for RAM, I give 1 gigabyte to a VM, and that's not really much these days. So the one thing you really want is hardware virtualization, which you have in most of the machines today anyway, like Intel or AMD. Yeah, and currently there's really just one machine with 12 gigabytes of RAM and one fast SSD, and that is running over 40 tests a day, I think, and that's enough for us at least. Yeah. Okay, so yeah, basically you can test anything that boots somehow. You could even test Windows if it was available somewhere. And yeah, initially the result checking was done with MD5 sums. Like I take a screenshot and I see the MD5 sum is this, and if it was a different one, it would not match. But that was a bit too cumbersome, so we created this reference image thing, mostly by Dominik Heidler, who did also the nice web interface to edit it. And then lately, the openSUSE team did a new version with openCV again. So that's really a useful tool. And then we have some audio tests where we have a virtualized sound card, and we capture the audio that comes out of it. So we can even see that the audio framework, like Pulse Audio, ALSA, the playback tool, you can play audio from Firefox and record it on the outside and see that's coming out. And to see the audio, we use DTMF, which is like and if we really see the right sequence coming out, then we say yes, green, let's check. Yeah, and initially the test was just running, and only when it finished we got some feedback. But Dominik added a live viewer, so while the test is running, you can just watch it, a bit like a VNC connection, but it's read-only, so everyone can just view it without the danger of messing up something. Yeah, and that's using Motion JPEG, which is just a multi-part JPEG, which has one image after another. Nice technology. Yeah, and he had some test progress viewer too, which means you have checkboxes at the side telling, okay, I'm now at step this, and next comes step this. And that's nice for viewing or comparing if it's really at the place it should be. And yeah, then when you find a bug, the developers usually come and say, do you have the logs? Can you give them to me? And I said, no, the test is already done and the new test started, so it overwrote the image. And that's bad. So I added a backlog, like keeping the last 15 images, and you can even download them too on the website. There's a small floppy disk image. And then you can get the whole image from the install and run it yourself with KVM locally. But if you just want the logs, it was still too hard because such a big image, and how do you loopback mount it, and the download time, it's too hard. So there's one test step now that uploads the logs from varlog as an archive, and you can download just that log archive from the web page separately. That's very easy, and you can sometimes even just append this as a Bugzilla attachment. So that's the part for the slides. There are some pointers, like the web page for the test backend, which is OS-autoinst, and the front-end page, which is openQA, with a scheduler and the web interface to create the reference images. And the GitHub, where there's all the code. No, this one has only half the code. That's the front-end part. And there's another one called OS-autoinst, where the backend, the test engine is. So if you just want to test single ISOs, you just need a test backend, the OS-autoinst part. And then you can say, okay, test me this video, and it will go and run and type and take screenshots and make you a video. And that part is much easier to set up than the whole part. It's mostly just installing the packages you need and saying run. So then we have time for some more questions.
Yeah.
Yeah.
Can you explain once more how you send the keys, what you need to be tested? So an installation starts, and then in the boot options, you type some options. How are they sent to KVM? What synchronizes the input with the testing?
I hope I understand it right. Well, there's some. If you have these test results here, you see these bluish entries on the left, and then it means it's links, and you can actually click on them. Like say, yeah, maybe here we want to change the software. It's a bit complicated, yeah. But actually Perl code, every test module, test step is one Perl module, which has a run function over there. And in the run function, we can use environment variables to decide if we want to do some part or not. We can use the sendQuery macros, and there is also here call to the function wait idle, which is one of the many synchronization functions that says, okay, at this point we check the processor CPU usage, and when it goes under this threshold, then okay, it's considered idle, and then we can continue there. And we have other synchronizations like wait still image, I think, and there it just waits up to a certain timeout for the screen to not change anymore. Like if you have a progress bar and the progress bar is moving, it will still wait, and when it's finished or when the progress bar blocks for a long time, then it will continue at that point.
Okay. And so by that send key function, you send keyboard typing or mouse clicks onto the screen. Yes?
Yeah, I send keyboard events.
Yes. Okay.
Yeah. And I also have send autotype macro where it sends many keystrokes to type strings because it's much easier that way.
So in fact, you could test for the installation of MySQL if that installs correctly, and you can log in and send an SQL statement and see if it creates all that. So
yeah, actually I have a test for that. Yeah, and but it's done a bit differently because you can script most parts of it. My test framework just puts in the script and runs the script, and the script says, okay, I install Apache, I install MySQL, I install PHP, and I install PHP myadmin, and then I do curl on this URL, and then I expect, or no, it's just a grep, and then I get a screenshot with the grep output, and if it says there, output is server type MariaDB, then I know, something must have worked. And it's pretty much an end-to-end test because it's using the web server with the PHP to go over the MySQL connection and really query this information. And if some part of this long chain would be broken, we would notice in this test. And that's I like this type of test much better than really testing small parts because you cover a lot of things with such a test. Okay. We have a question here.
So you can send keystrokes. Can you also somehow send mouse events in case there's no keyboard support, or is it really limited to screens or stuff that is?
Yeah, in theory, we can move the mouse and we can say click the mouse button and unclick, but there's a bug in KVM for over 3 years. And we have a very simple bug fix that is not accepted upstream because it does not cover this case and that case. And yeah, so it's a bit hard. And the other hard part is, of course, if you want to click a button, where is this button to click? So you would need some image matching again to say, okay, I want to click a button that looks like this, and then you find the position, and then you don't want to click on next to the button, but in the middle of the button maybe, or on a certain part of it. So it can be a bit tricky. So for now, we just move the mouse pointer off to not interfere with the tests. And if you really have software that can not be used with a keyboard, it's bad software. Really. Because they're disabled people and they have really big trouble with mouses. And so far, Just is really great software. You can do anything with keyboard, and in some places it's a bit hard because you have to do tap, 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 cursor down, tap, enter, and that's maybe not so nice to write as a code or to change later, but it still works pretty well. Yeah, but that is okay.
So for web apps, what we are using for SUSE Manager, for example, you can actually click a button in the DOM tree with a cucumber and stuff. Would that be something that you would integrate as a module here, or do you think that's kind of a completely different area of tests that should be run separately?
Yeah, yeah, of course you can run it as a separate test completely independent of openQA. But in one instance I have done it for Just, where we tested the Qt UI, and we used another framework in openQA, which is called Zicoli. And Zicoli is Java software using JSON Python interpreter. And with that you can write tests in a very different way, and you can say click some button that looks like this, and it uses the libopencv as well. So it would just install the test framework in this VM that's currently running, and then just launch the test and see what it returns. So you can sort of integrate other frameworks.
So just for the others, the cool thing about what we are doing in SUSE Manager testing with the Cucumber, and I don't know what the module is, it reads the DOM tree within a browser, and it knows that it's a button, and regardless what the color of the button is, because it goes into the tree and says, okay, this is where I am in the object tree, and I send a click event like you could do from JavaScript. And that works pretty well to click through all the screens in a web app. Of course, you don't get the pictures, so if the CSS looks ugly, you don't know, but you know that it works. Like you can create a user, test whether the user exists, change the password, do something with that user, and so on. And at the same time, also in the backend, do things like, okay, does the SQL database actually get this string, and so on. That's pretty cool too.
Yeah, but I think you can integrate all types of test frameworks in here. Of course, if it runs for a day, it's maybe not that useful because usually you want your overall test run to be rather fast. They did it at one point with the file system tests. There's an XFS test suite which can test any file system, and we used it to do some stress testing on ButterFS when we did it with SP2, I think. And there we found some ugly crashes as well. Yeah.
So maybe one more question on my part. If I want to test more than one server, like I need a backend and a frontend, is that something that openQA could do today, or is it like out of the picture?
Yeah, under certain circumstances, if you can run both of them in the same machine. For example, I started doing it like with the Apache and the MySQL. I have the server and the client on the same machine, or you can do it with email, that you install Postfix as an email server and then test Thunderbird as an email client. So you can test both parts on one machine, or you could set up the server on the outside and have it always running and just test the client in a test run. But currently it is not made for testing more complex deployments. But that's okay for the openSUSE use case, I think. For example, for our SUSE Cloud OpenStack, we have other frameworks that do it differently, and they use a number of VMs, and then they can check the interaction between the VMs. But that's still another framework. So, do we have more questions? Or no? Great. Then I thank you all for coming and for being so nice.